Hello viewers, you're welcome back to Success Arena Academy. In my previous video on wave, we took a look at wave and the types of wave. And I tried to give you the two different types of wave based on the medium in which they are traveling. Altogether, today we are going to be looking at classification of wave based on their mode of traveling, which is known as propagation. Propagation. Now, if you are new to my channel and you've not watched my previous video, there will be a link in the description box below that will take you to this previous video to understand more about classification of wave based on the medium. Now, if you are new, please don't forget to subscribe to my channel and click on that notification bell that look like normal bell that we are using in school. Click on that bell and make sure that you put the bell in all to receive all notifications whenever I release a video for you, and share the video with your friends and family. Thank you. Now, today I'm going to be taking you through how the types of wave based on this propagation. What is my propagation? The layman language, propagation simply means movement, how they have been moving from one point to another. Wave has different forms of movement. There are some waves that are moving wave, while some of them does not move. They are stagnant in one position in the medium. Altogether, based on this, waves are classified into two types, which we have the progressive wave, we have the progressive wave, and then we have the standing wave. Now, based on propagation, waves are classified into two: progressive wave and standing wave. Now, one said progressive wave. What do you mean by progressive wave? A progressive wave is a wave that is traveling, that are traveling from one point to another. Altogether, in another word, we call it a traveling wave. Altogether, while a standing wave are simply stationary wave that does not move between one end. Majorly, this standing wave can be generated, one, in a pipe. It can be generated in a pipe, and number two, it can also be generated in a fixed string, like the string of a guitar. Altogether, the string of a piano and the likes. The kind of wave that is generated there is a standing wave that does not travel. When they tend to travel, let me say I have these two fixed ends. When they tend to travel from one end to another end, they tend to return back to their initial position by what? Moving in another manner. Let me say they are traveling like this. They tend to return back in this manner back to their what? Initial position. Why? There is no movement along this direction. When they got here, due to reflection, it returned them back to this place. And they got to this place also, they tend to reflect backward to the same initial position. Altogether, these are standing waves. So please don't forget, they are generated in a pipe, and they can also be generated in fixed string. Altogether, now, you see, this progressive wave that I said they are traveling wave can be classified into two types. There are two types of progressive wave. We have what we call the longitudinal wave, and we have the transverse wave. Now, you see, when we say longitudinal wave are waves that are in which the particles of the medium are propagating, or let me say they are traveling in the same direction as the direction of travel of the wave. Altogether, now, I said earlier on in my last video, I said it is the particles of the medium that are traveling, not the whole medium. When the particles travel from one point to another, they tend to disturb the medium. They tend to disturb the medium. Now, see longitudinal wave, we said the particles are moving along the same direction as the medium, as the wave. Simply means when a wave is generated along this direction, the wave is going like this, the particles of that medium tend to also drift along that same direction of travel of the wave. This is the direction of the wave. This is the particles of the medium. So they tend to drift along that direction. Majorly, this longitudinal wave are mostly found in sound wave. And you get this kind of travel is found in what? Sound wave. It simply means the major example of wave that are longitudinal is sound wave. Sound wave. Although water wave can also be longitudinal in nature. Altogether, water wave can be longitudinal in nature. It can produce the same thing just like sound wave. Altogether, so water wave has a kind of a dual nature, but mostly water tends to be more transverse than longitudinal. But it also has the characteristic of a longitudinal wave. Are we together? Now, that is for sound wave. So sound wave is the major example of wave that is longitudinal in nature. Now, the next type of wave that we have is transverse wave. Now, from the word transverse, it simply means a wave in which the particles of the medium are propagating perpendicularly to the direction of travel of the wave. Altogether, that means the particles of the medium are moving perpendicularly to the direction of travel of the wave. Now, take a look at this. They tend to undergo this kind of movement. Let me try to draw something right here. Now, this kind of wave tend to propagate this kind of movement like this, whereby they tend to move like this, in this manner, whereby each of the particles of the medium, they tend to displace up and down in a perpendicular manner, moving up, down, while the wave is traveling along this direction. The wave is moving like this, but the particles are, sorry, let me use this manner, okay. The wave is moving like this, but the particles are moving up and down, in a perpendicular manner at an angle of 90 degrees to the direction of travel of the wave. This kind of wave here is known as a transverse wave. Transverse wave. Now, there are varieties of examples of this transverse wave. One of the examples that we have is string wave. String wave. That is, wave on a string is an example. Number one. Number two, we can also have water wave. Water wave is also transverse in nature. And don't forget, another major example of wave that are also transverse in nature, as I said earlier in my initial video, is all electromagnetic wave. They are transverse because they are formed due to the oscillation of the magnetic and the electric field in space altogether. So they also have this same nature of propagation in which the electric field is moving perpendicularly, is transversing perpendicularly to the electromagnetic field and magnetic field. If this is the electric field, this is the magnetic field for electromagnetic wave. Now, the movement of the magnetic field is perpendicular to the movement of the electric field, such that the wave tends to be traveling like this, in this manner. Look up, in this manner. They are tend towards, whereby this is the electric field and the magnetic field is trying to move along this direction, such that they will have the same property as a transverse wave. So, like all electromagnetic wave, all electromagnetic wave is also transverse in nature. Now, these are the classification of wave based on their propagation. Please, if you have any question that you don't really understand, please drop it for me in the comment box section below. I'm going to reply your message, and don't forget to share my video and like, then subscribe. Thank you for watching this video. Meet you in the next video. Thank you.